Imagine a world teetering on the edge of collapse. A world desperately searching for a mind brilliant enough, audacious enough, to save it from the brink. That mind belonged to a man named Alan Turing. Born in London in 1912, Turing was never one to follow the crowd. He was a solitary child, a deeply independent thinker who found his true companions in the abstract worlds of mathematics and science. While his English public school tried to mold him with its rigid curriculum, Turing's mind was already racing ahead, driven not by teachers, but by his own relentless curiosity. He was the kind of boy who would derive the laws of motion on his own. Not because he was assigned to, but simply because he wanted to understand how the universe worked. This insatiable curiosity eventually led him to the hallowed halls of Cambridge University. There, amidst the intellectual giants of the era, Turing set his sights on one of the biggest, most profound questions of the 20th century. Could a machine think? This wasn't just a philosophical daydream. It was a deep mathematical problem. And in 1936, at the young age of 24, he answered it. He published a groundbreaking paper on computable numbers, which introduced a concept so revolutionary it would change the course of human history: the Turing machine. Now, this wasn't a physical machine with gears and levers. It was a purely theoretical device, a concept existing only on paper. But this abstract idea machine that could read symbols on a tape and perform any logical calculation based on a set of rules was the conceptual blueprint for every single computer, every smartphone, every piece of digital technology we use today. It was the birth of the digital age, imagined in the mind of one man. But just as Turing was exploring these abstract frontiers, the world was descending into the terrifying reality of World War II. His theoretical genius was about to be called upon for a very real, very urgent problem. The German war machine had a seemingly unbreakable weapon, the Enigma machine. This complex device scrambled naval communications, creating a code so sophisticated that it gave German U-boats a deadly, invisible advantage in the Atlantic. Convoys carrying vital supplies were being sunk at an alarming rate, and the Allies were losing the battle for the seas. Turing was recruited to a top-secret location known as Bletchley Park, a sprawling estate that became the nerve center of the British code-breaking effort. Here, the greatest minds in the country gathered, working frantically to decipher the Enigma's daily changing codes. But while others attacked the problem with pen and paper, Turing had a radical realization. To beat a machine, you needed a machine. A faster, more powerful machine. He spearheaded the effort to design and build an electromechanical marvel called the bomb. This wasn't a bomb in the explosive sense, but a device that would methodically, relentlessly, and rapidly test millions of possible Enigma settings every single day. The clicking and whirring of the bomb was the sound of logic at war. It wasn't the world's first computer, but it was a crucial stepping stone, a purpose-built machine, designed to process complex logic and language at a speed no human team could match. In essence, Turing was turning his theoretical Turing machine into a physical reality, a weapon forged from mathematics that would crack the German codes wide open. The impact of the bomb, and the work of the entire Bletchley Park team, was nothing short of miraculous. Historians estimate that their success in cracking the Enigma codes shortened the war by at least 2 to 4 years. Think about that. Years of conflict erased, countless live soldiers and civilians saved. The tide of the war was turned, not just by soldiers on the battlefield, but by the quiet, tireless work of these secret codebreakers. Yet, this monumental victory came with a heavy price for those involved. The Official Secrets Act bound them to absolute silence. Turing and his colleagues were heroes who could never be celebrated, their achievements locked away from public knowledge for decades. They had saved the world, but the world would never know. After the war, with the world trying to piece itself back together, Turing returned to his first love, the question of machine intelligence. He moved to the University of Manchester, where he was instrumental in designing the Manchester Mark I, one of the world's first true stored program computers. He was no longer just theorizing. He was building the very machines he had once only dreamed of. Then, in 1950, he published another seminal paper, Computing Machinery and Intelligence. In it, he proposed a simple, elegant way to answer his lifelong question. It became known as the Turing test. The idea was this: If a human judge engages in a natural language conversation with two hidden entities, one a human, the other a machine, and cannot reliably tell which is which, then the machine can be said to have exhibited intelligent behavior. With this single idea, Turing didn't just contribute to a field. He single-handedly created the entire field of artificial intelligence, as we know it today. Turing's genius was reshaping the future, but his present was about to be shattered by the cruel prejudices of his time. In 1952, at the absolute peak of his career, his life took a devastating turn. Turing was an openly gay man in a country where homosexuality was a criminal offense. Following a report of a burglary at his home, he naively admitted his relationship with another man to the police. He was promptly arrested and prosecuted for gross indecency. The court gave him a barbaric choice: go to prison or submit to chemical castration through hormone treatment. Desperate to continue his work, Turing chose the latter. This brutal, dehumanizing treatment had a catastrophic effect on him, both physically and emotionally. His brilliant mind was clouded, his spirit broken. Just 2 years later, at the age of 41, Alan Turing was found dead. The official verdict was suicide. The man who invented the conceptual basis for the modern computer. The man whose machine cracked the Enigma code and secured victory in a global war was destroyed by the very society he had saved. For decades, his true role in history remained a secret, shrouded by his wartime oath and tainted by his unjust conviction. It wasn't until 2013, nearly 60 years after his death, that Queen Elizabeth II granted him a posthumous royal pardon, a long overdue act of justice. Finally, the world began to recognize Alan Turing for who he was: a visionary, a war hero, and the true father of the digital age. His story is a powerful reminder that genius can be found in the most unexpected places, and a tragic testament to the human cost of intolerance. So, here's a thought for you. With today's incredible advancements in chatbots and AI, do you think any modern system has truly passed the original Turing test? Can a machine truly convince you it's human? Let us know your thoughts in the comments below. If this story of incredible genius and heartbreaking tragedy moved you, please hit that like button and subscribe for more deep dives into the lives of the unsung heroes who shaped our modern world. Thank you for watching.